Hey, how's it going out there, folks? Welcome back here to a Friday. Finally made it here to the weekend. It's a cold and rainy one out here in Northern California. About 11:01 a.m. California time. December 13th, 2024 is the date. Latest activity shows a 4.6 earthquake here. Let's see exactly where that's at. Stand by for just a second. I'm going to cover a bunch of Cascadia activity here. 4.6 looks like a newer quake here, maybe around the Iran area, looks like, potentially over here across this region. Nothing big. In fact, if we look at the last 24 hours of earthquake activity out here, active nonetheless, but nothing major going on yet. So we'll get to the rest of the earthquake activity here in a little bit. I want to talk about the Cascadia subduction zone here a little bit more in focus on that point, because we have been seeing a lot of tremor activity here recently across the southern end of the Cascadia subduction zone. If we look at the last month of data, most of it came up here around the 25th of November, and the majority of it focused down here across the southern end of the Cascadia subduction zone. Now, while it's, obviously, we've seen elevated tremor out here before in the past, but at the same time, this is accompanying these larger quakes out here as well, including that 7-pointer that struck off the Northern California coastline here a few days ago. Hasn't been that long, a few days ago. So I'm primarily focused here on watching the Cascadia subduction zone because there's definitely a high percentage here, possibility that we could see something pop here very soon on the southern end. This is a really interesting article here. I'll leave the links for everyone to check out if you wish. We're going to cover it a little bit here in detail. It's called survivingcascadia.com. And this chart right here, there's a number of charts, and we're going to go down this chart here and explain it. But this right here covers the last 10,272 years of Cascadia subduction zone earthquakes, and that includes partial ruptures and full ruptures there. Most of the time we see the majority of the ruptures take place in the southern end. That's the Northern California, southern coast of Oregon area. Now, this is number of years between major earthquakes here. Okay, now this guy went into some pretty neat detail here on the years in between regular intervals and whatnot, and the possibilities of reoccurrence intervals for the southern margin. So definitely check this out, survivingcascadia.com. Got to give this website credit. So if you read here, intervals over 360 years are shown in the red. Now, that doesn't happen all that often. You hear someone saying, intervals of earthquakes run between 250 and up to 500 years along the Cascadia. So that's just an average. But if you look here, the majority of them have been lower than that. So intervals over 360 years are shown in the red, while shorter ones are in the gray here, with the last one in between the rupture about 216 years. So only 6 intervals stretch above the black line. Failure analysis suggests that by the year 2060, Cascadia will have exceeded 85% of the reoccurrence intervals for the southern margin. Let's go down here and include some of the other ones across the southern end of the Cascadia. This area right here. Okay, so the black lines here represent how long the Pacific Northwest has already gone since the last Cascadia megathrust earthquake. So here's the map, right? We're at 324 years. 93% of the time, the fault here, the southern end, has not had to wait 324 years for the strain to break it. Look at this. There's only been 2 times here in the past several events, 28 of them there to be exact, that the year, right, the accumulation year in between ruptures, only 2 times that it was above 324 years, and that's where we're at right now for the southern end. So 93% of the time, the fault has not had to wait 324 years for the strain to break it. The longest span of time between major Cascadia earthquakes in the past 4 millennia was only 291 years until now. So that tells you something right there, just on this graph, right? That we're, we can't wait much longer. I mean, I would love to not see it happen, but we're at the end of an age, so to speak, here of quietness along the Cascadia. And there's a lot of information to look at here if you really think about it. Let me check out this other map here. Here's another little neat graph. I'll blow this up so you guys can see it a little bit better. Interval events, it goes back to the last 18 of them. Okay, so this is the average intervals here of between years. Average. So you take that graph I just showed you there, the 500 potentially up to 500 and something, and then you average them out here with some of these lower numbers. See, 67 years in between events, 92. Some of these are really low, some of them are really high, so you come up with the average. The southern segment down here, this is Northern California. There's Mount Shasta, Oregon, Washington, and so on. And here's the Gorda Ridges. It's excuse me. It makes sense here that we see an average interval here on a shorter time period because of the way the dynamics are set here. You got a spreading seafloor center pushing the Gorda plate underneath the North American plate here. That's the southern end. So up there across the, let me show you guys the other map here. Up here across the north, it takes a longer time for an occurrence to occur on the Cascadia subduction zone, just because of the dynamics out here. Spreading seafloor center, adding further strain faster. Out here, strike slip boundaries, a little bit of spreading seafloor center. Up north, less, right? So longer time frame there to build up strain, but we're looking at 230 years on a regular interval here for the southern end, and it's been 324 years. So to say that this is overdue in terms of a larger quake on the southern end is an understatement, I think, because we're way over that period, way over it. 20 megathrust earthquakes, includes magnitudes 8s and above, have occurred in the most recent 4,000 years. None of the intervals between them stretched beyond 300 years. And again, keep in mind that number, that we're at 324 years. In other words, we have currently gone longer than 100% of known times between earthquakes during the most recent 4,000 years. Again, 324 years since the last event. Overall, 27 of the 41 intervals were less than 300 years in length. So when we tell ourselves the story of how often these earthquakes occur in the Pacific Northwest, it may be accurate to say, that if you think about it on this time frame here, if we're going to wait, 500 years between a major event, we're safe, right? We're only at 324 years, so we still have 100 and something years to go. No, that's not the case when you think of average intervals here. The average high is 500, but if you look at the past events out here, in the last 6,000 years, 20 megathrust earthquakes, none of the intervals between them stretch beyond 300 years. So we're living right now in a time here of some interesting earthquake activity, right? A lot of people say, well, nothing's going to happen. They always see earthquake activity out here, right? And that's a fact. We do always see a lot of earthquake activity out here. But I'm looking at some pinpoint things here, like elevated tremor, right? I've been noticing a lot here over the last couple months. Aside from that 7-pointer, every time we get elevated tremor activity here on the southern end, we notice elevated earthquake activity, whether it's along the Cascadia, back over across the plate boundary here, or just along the coastline. So we're living, like I say, we're living at some interesting times here. I want to show you guys and how we know. You think about this as well. This is the Crescent City area, Klamath, Northern California region here. You got Eureka, Fortuna. Now this is just one station here, the Crescent City area. As this area here, this is more into the southern end of the Cascadia, away from the Triple Point Junction that sits down there across the Eureka area, which is right here where the 7-pointer struck. So further up shore here, right about this area, is where that GPS station's at. And If you look on the bottom here, this is a vertical displacement. This is not a volcano. This is just a chunk of land out here, the Pacific coast. And ever since 1700, this chart has been going up and up and up and up. Now, I don't want to do the math here, right? But it looks like in the last 24 years, we've gone up. This would be 0.40, so that'd be 80 mm. Right, if my math is correct. There's a little bit of downsloping right here, meaning that's actually a little odd, a little interesting. But if you think about the long-term slope here, this whole land has been going up and up and up because of the strain here along the Cascadia subduction zone since a big earthquake back in 1700. I'll let you guys do the math there. I don't feel like doing that right now, but that's a lot. So you look at these little GPS measurements and see that the land is rising. Look at the elevated tremor downstream, right, underneath the Cascadia subduction zone. That is further adding strain up here across the locked area. That's why that land is rising, kind of like a spring out here. When it does pop here, that land will subside. That's the bad thing here. I can't remember the exact feet, but once you come up with the math, then you'll get the around the average amount of land droppage there following that release of the tension there over 324 years. So we got to watch this pretty closely. We could put this off all, on every single video. Nothing's going to happen. Nothing's going to happen. They always say that. But you have to look at these little periods of increasing activity. Elevated tremor, we've seen a 7-pointer out here recently. And yes, that was off of the Cascadia towards the southern end. Let me bring up 7 days. Has it been really over 7 days already? Wow, time's just flying by. So that earthquake out here on the off the Mendocino triple point boundary here. This is actually going to be the Pacific plate and the Gorda plate up here to the north. So a little bit of earthquake activity here. Have we really seen anything specifically on the Cascadia? No, a little bit down here across the southern end. There's been a couple earthquakes here and more defined closer to the plate boundary. But from what I've read, this thing doesn't just see, some 5s and 6s and then it decides to go. It just goes without warning, so to speak here. We don't see, an elevated earthquake event and then a big one. It just goes without warning. But we do have these little, little hints, little clues to watch here in terms of tremor uptick, what's going on following the tremor activity here, what's going on out here across the Blanco fracture zone. There was a number of earthquakes out here across the Gorda ridges here recently as well, elevating the tension because this is a spreading seafloor center here. So you get the separation of the plate here, the plate boundary. That's why we have those ridges, adding the further strain. You guessed it, right here on the southern end of the Cascadia subduction zone. I want to show you guys here. Let's go back a little bit. I just want to go back to the last year, 2003. And we're going to draw a little rectangle map here across this area of the Gorda ridges and show you guys the a decent amount of earthquake activity out there recently. I don't want to include all the activity here in Northern California, but just want to do that. Excuse me. So this is the last year. There was actually one earthquake right on the Cascadia subduction zone earlier this year, 4.3. And I bet you that was following all this activity here along the Gorda ridges there back in August, June, February. It seems like a mixed bag of dates out here, but it's been elevated across this area. So when we see elevated activity out here across the spreading seafloor center, strain continues to build up because that's pushing that plate here, the Gorda plate, underneath this area to the east there, the North American region. Also a lot of activity here across the Blanco fracture zone. Strike slip boundary, but at the same time you get some spreading seafloor centers here at the southern end. That's why the ridges are building up here. The Blanco, what's it called? Transform fault zone, but that's a result of strain from this area here. And again, adding more tension across the southern end. They mentioned here that, let's see where that was at. This is one, let's see, since 2012, those asking the question have likely found the answer. So that article is a little bit older. There's a 37% chance of a megathrust earthquake occurring along the Cascadia subduction zone in the next 50 years. Many read that quote and flip it. Well, that's like saying there's a 63% chance it won't happen in the next 50 years. You know, optimism, right? Hopefully it doesn't happen. But you got to think of this time period that we're living in right now. So, nearly 15 years ago, Oregon State University professor, this guy right here, Goldfinger, said perhaps more striking than the probability numbers is that we can now say that we have already gone longer without an earthquake than 75% of the known times between earthquakes in the last 10,000 years. That's crazy, right? If you really think about it. Yeah, probability originates from a 184-page USGS research publication. 2012. A lot of time has passed since then. 12 years. So I'm not going to read into it. If you guys have an hour or so, that would be definitely a worthwhile read and looking over these graphs here. But I pointed out some interesting little facts there. And I think the big one down here across the southern end states some information here that's worth the noting here. Look at that. Here's the last 28 incidents there. Cascadia earthquakes. 93% of the time, the fault has not had to wait 324 years for the strain to break it. The longest span of time between major Cascadia earthquakes in the past 4 millennia, so we're just talking here on the past 28 events, was only 291 years until now. So why is it waiting so long? But I think we may not have to wait longer, folks. I'm not wishing for this to happen. I've been studying this stuff for quite a while and looking at these elevated events out here. And if you think about it, knowledge is information. It's not fear-mongering, but it's good to be on guard on what's going on across the West Coast here. And there's a little relationship here between the Cascadia and potentially the San Andreas Fault as well. What I find weird is the relationship between the last known major rupture here across the southern branch of the San Andreas Fault was over 300 years ago. They're thinking about 324 years ago or so as well. Compare that to the last, that was the last full rupture of the Cascadia, the 9-pointer, 324 years ago. So is there, a possibility that one may trigger the other? It's possible. If it just seems like a coincidence. It seems a little odd coincidence there that we would have that same time frame between those two large events here, literally, side by side in terms of geology size, that is. So it's just best to be prepared, folks, and got to have an earthquake plan. That little 7-pointer, and I say little because an 8.1 or something greater up here is going to make that 7-pointer feel like just a day at the beach. That's just a friendly reminder to make everyone aware. Obviously they're aware, but they got to be prepared as well for something bigger out here. I feel we're living in times of some elevated seismic events out here across California, the West Coast. Southern California has seen it here in the last few months. We've had more 4s out here, and I keep saying that because it's pretty important to get the information out. This came from the horse's mouth itself. Well, Dr. Lucy Jones here, world-known seismologist, stated on live TV that we've seen more 4s out here this year than at any time since about 1980 or so, 1984. So that alone right there tells us that we're looking at an elevated seismic event out here across the area. Not only Southern California, but I think it's the entire West Coast out here. So there's a lot of information here. I will provide the links here so you guys can check it out. You know, you got to remember average intervals here vary depending on the size and rupture of the fault, whether it's a full rupture or the southern end. Average ruptures for the southern end run about 230 years on average. On average, 220 years or so. A little bit higher up, obviously, as we go up the Cascadia. They're talking about 480 to 505 years for that average interval. And again, it's got to do with the dynamics out here. There's more strain down at the southern end because of this area right here. The Gorda Ridge is a seafloor separation area, and the transform boundary here adding further strain across the southern end. And that's that's my neck of the woods here. So that we have to be cautious of. Hold on a second. Let me check something here real quick. Not for sure what that knocking on the door was. Missy Mimi's normally knocks when there's something going on, but all right, still got a little cold out here. Trying to recover from that. Actually, it's a new cold, it feels like. I'm not for sure where that came from, but man, this year it just seems like there's all sorts of stuff going around in the air, in the food, everything. Pretty crazy. All right, let's go ahead and talk about, and we'll cover this a little bit more. We'll keep checking back on the tremor map up here, see what we got here for tonight's tremor. As far as latest earthquake activity goes, across Northern California, there's the earthquakes that they're reporting. Only 9 earthquakes in the last 24 hours. Again, there's nothing underneath 2.2 or so. Let's take a look at the seismograph stations. There's a little earthquake showing up on the Petrolia station. So it's these little events here. They're probably ones, maybe 1.5 or so. 2-pointer, 2.5 and above will show up across the Dinsmore station here, but they, for whatever reason, chose not to report all the smaller quakes here associated with that 7-pointer here recently. I'm not in charge of the USGS. I think transparency would be key, right? And even producing and putting out those smaller quakes there that are happening across this area. But for whatever reason, they're only reporting a small amount. What they did report here, some 2s and some upper 3s here in the last 24 hours. Bringing the total tally here, we got to go back the last 30 days. Looks like about 416 earthquakes or so in that cluster following that 7.0 earthquake. The rest of Northern California, Oregon, pretty quiet for now. There's the activity there across Nevada. 32 earthquakes. These guys are reporting all the earthquakes here, the ones and the smaller quakes. Why there's a difference between that and this? Well, we've seen a lot of earthquake activity out there. Lots of 1s and 2s coming in and nothing being reported. I watched the seismographs. Been watching it for a week now. Seen a lot of activity showing up. Nothing being reported. But they are here. I don't get it. Why this area, not Northern California? So total tally here, 310 earthquakes. So just over 300 following that 5.8 earthquake out in Nevada a few days ago. The Bay Area, pretty quiet. Southern California has been awfully quiet as well. Seems like most of the movement has been focused north here. It doesn't mean that this area, obviously continues to see the possibility here of some larger events. Last 4 months or so has been quite active out here. Just a few days here of some quietness going on across California, but it's not always going to stay that way. A little bit of sequence of events down there across the Inglewood area. A couple 1s showing up off of the, looks like it's a Newport Inglewood Rose Canyon fault. Pretty dangerous fault system there that runs through the Los Angeles area. Nothing on the Puente Hills Thrust Fault for now. Just a couple smaller quakes there around the area, but we'll continue to watch it, folks. Yellowstone, nothing showing up, but I do want to double check that, see what we have here. Really not a whole lot going on there across Yellowstone that I can see. Still haven't found out what that earthquake was from yesterday or late last night. There's a little earthquake reading there on the graph, but really nothing being reported out there across the area. And it doesn't look like there's any large events out there across the globe in the last 24 hours. That would make me think that that's the earthquake. Last 24 hours, the largest quake is going to be this 5.3. Solomon Islands from last night. A couple smaller quakes there through Kansas, down through the oil fields of Texas. New Madrid seismic zone, quiet for now. As far as newer activity goes, in the last 24 hours, got a little bit of movement happening down there in the New Zealand area, it looks like. Some threes, even a 4.7 there along the Kermadec Trench. Some slight uptick there across Alaska. Let's see what we got going on out here. The Aleutian Trench here been pretty active as well. More notably, that swarm here of 6s and 5s and 4s and a whole bunch of other earthquakes there outside the Adak area of Alaska. A little bit of migration here along the Aleutian Trench in the last couple days is 4.4. And a couple other earthquakes out there. There's another 4-pointer, one of the more recent ones, a little bit further east along the Aleutian Trench. So it looks as though, this area still needs to be watched quite closely. Japan area seeing some movement, deeper quakes here into the Kuril-Kamchatka. Nothing showing up here on the USGS map, but it looks like the EMSC model is reporting a little bit of earthquake activity there today. Nothing big. And typical movement there across the areas of the Indonesia Islands region. Across this area of the world, got a little swarm going on there. It looks like outside the Turkey area, some 2s scattered and stacked up there. Looks like around this area of Greece, potentially. 4.9 early this morning, north of the North Aegean Trough area. Big earthquakes can take place out here. For now, a little 4-pointer. The Atlantic Ocean, pretty quiet. Nothing major happening down there for now. We'll continue to watch here, Northern California, Gulf of Alaska area, and the, of course, the Kuril-Kamchatka Trench here. Space weather activity, couple let's see what we got here. M flares or C flares? Looks like a couple M flares here in the last 24 hours, just barely reaching up here into the M flare class. Maybe 2 right there as well. So it looks like we're starting to get a little active here in terms of the sunspot complexity here. Man, I'm lost without the colored magnetogram image. There's an active area, looks like across the eastern limb here, but maybe one right here, center disk. Not for sure exactly where these little M flares are coming from. 37 or 3917. Okay, looks like this area right here. But aside from that, magnetogram still offline. Hopefully this comes back soon. No major auroras in the forecast there, as we could see. Pretty green across the board. Flare threat, I guess, will remain isolated here for some M flare activity. Maybe an X flare. I don't know. It doesn't look all that active for now, but a little hard to tell without the complexity magnetogram image that I'm used to observing. Aurora activity, as I mentioned, fairly minimal. Not a whole lot going on. Storm Prediction Center out here. Not a whole lot here in the next couple days. Just some thunderstorm activity associated with this low pressure there along the west coast and across the southern plain states. Far as the weather models go, there's our storm system. Been raining most of the morning. That is expected to ramp up through the day, bringing with it some decent precipitation rates here. Look like the Bay Area is going to get hammered. Overall, we should pick up another couple inches of rainfall from this system. A little bit weaker one behind that as we head into early next week in the west coast. And then I guess we'll have to see what happens. Wow, look at that up north. Around Friday, December 20th. That'd be a Thursday at 6 p.m., the 26th time period. But that could change, obviously. That's a heavy-duty storm system up there across the Pacific Northwest. that's a ways out there. But we'll take any rain we can get here in California right now. And as far as Christmas time period goes, it's a ways out there, so it can't be 100% accurate on what this is going to look like. But we'll keep checking back on it. Right now, I don't see any major travel issues. A little bit of colder air here across the Great Lakes area. Some rain across the Pacific Northwest for the Christmas time period. But again, we'll check back at a later date. As far as any major close approach asteroids go, let's see what we got here. Anything of interest? Everything's a couple million miles away from the planet here, so really nothing of any major concern for now. All right, seismograph stations there look pretty quiet. We'll continue to watch and keep an eye on the Cascadia activity. You know, it's this article is really good. I just found it. Not for sure why I didn't come across this sooner, but it's definitely worth the read here. There's a lot of different information here, talking about timing, shaking, subsidence of the land. You name it. You know, this would take me a couple hours to try to explain everything here, but it's well worth it. I'm going to bookmark this page myself. It explains the slow slip events there. A whole bunch of stuff here, so I'll provide the links here in this update video in the description below. So have a good day. Enjoy your Friday. Take it easy. Stay safe out there, folks, and we'll catch you guys back out here for the Friday night update. Unless something major happens, that is. Have a good one.